Hello, we would like to talk a little about tides, especially about how tides are formed. We will explore two theories, but we'll to have a basic understanding before we can do that. So I'll just explain a few scientific terms. Our first term is tide, tide, and it is the periodic rise and fall in a body of water on Earth or on other planets. You have high tides when the water level is high, and you have low tides when the water is low. Then we have tidal bulge as our second term. It is the two bulges of water created by the moon's gravitational force and two other forces that we'll talk about later, and they will be explained later. Our third term is gravity, and it is the force by which all matter with energy attracts each other. It was discovered by Sir Isaac Newton, and the more mass an object has, the greater a gravitational pull it has. Our fourth and fifth term are neap and spring tides. Neap tides are the lowest possible tides because the moon and the sun negate each other's pull, and therefore it forms a very small bulge compared to spring tides, which are the largest possible tides you can have, or they can be. It is when the sun and the moon align and they pull the water away from Earth at a greater force. Centrifugal force is a inertial force, and it is our last term. It is a so-called fake force because it only exists from a certain point of view. In this case, with the merry-go-round, it would be this guy's point of view, where he is getting pushed off the merry-go-round. But an observer of the situation might see that he's actually traveling at a straight line. So now he's not being pushed off, he's actually traveling at a straight line off the merry-go-round. The last thing we need to understand is the fixed rotation of the moon. The moon always faces the Earth with the same side when it's rotating around the Earth. So, but the Earth is rotating about its own axis, which is always tilted at a 23-degree angle, I think. While the moon always rotates around the Earth with the same side towards the Earth moves around the sun with the same point always pointing the same way. So the Earth moves around like this, while the moon would rotate around like this. So always keeping the same side pointing at the Earth.
I'm now going to explain the first of our two theories on why tides exist. The most prevalent and wrong theory on why tides exist is as follows. On different parts of the Earth, the force of the gravitational pull from the moon will be different depending on distance to the moon. So the gravitational pull from the moon will be stronger here than it will be here, and stronger here than it will be there. So what many people believe is that the oceans are being raised sort of by this differential in the moon's gravity. So the moon is pulling the oceans to bulge on this side of the Earth, and this point on Earth is being pulled more towards the moon than this one. So the water on this side is sort of left behind by the Earth moving closer. Part of this is true. There is in fact a difference in gravity between these 3 points depending on the moon's distance to the Earth. But it's not what is causing the tides. In this case, the math simply doesn't make sense. The tidal acceleration on objects due to this difference ends up being 1/10,000,000th of an Earth gram, which wouldn't even be noticeable if our planet didn't even have a gravitational force, but it does, so we will never ever notice this difference. If that is the case, how do tides work then? Instead of thinking of it as the oceans being stretched on opposite ends of the Earth out to bulge, you have to think of it as the water being squeezed towards these points on the Earth-Moon line. So, To understand this phenomenon, you have to look at this graph. You have to look at points that are not on the Earth-Moon line. This point, for example. This point is being pulled towards the Moon, just as this point is being pulled towards the Moon as well. Now, if you map this out, you can actually see that the tidal acceleration here then would make out to be downwards force, which would mean that on this point of the Earth's surface, the tides are being pulled down, sort of. So, if you do this with all the points on the Earth itself, you will end up with a vector looking something like this. And as you can clearly see here, these points would be experiencing low tides, while these points would be experiencing high tides. And this is not because they're being stretched by the difference in the Moon's gravity, depending on where you are on the Earth, but rather the water here being squeezed up towards the Earth-Moon line, where it would amass and bulge, basically. And if you want to see how that works in a moon cycle, you can simply look at this animation. Here you can see the tidal acceleration during a moon cycle, where the moon is moving around, and these lines representing the squeezing of the water towards the Earth-Moon line is being represented as in an animation. The force that is actually like pushing the water towards the Earth-Moon line, it's actually very tiny, because planet Earth is covered in like 70% water, these tiny forces on all of this water end up making a pretty substantial difference in water pressure anyway. So instead of thinking of it as this water being stretched, you should think of it as this and this water being pushed towards this and this part of the Earth.
Hello, I'm gonna tell about the second theory of the tidal waves. This theory, like the first one, thinks that the first bulge is created by the moon's gravity. But unlike the first theory, it don't believe that the second bulge is created with the same gravity as the first bulge. This theory thinks that the second bulge is created by the rotation around the moon and the Earth's center of gravity, which is here. This drawing is a drawing of the Earth and the moon's rotation around the center of gravity, where the first position is here, and then it goes around here and here, which is shown in this animation here. Something that is the centrifugal force that creates the second bulge, which probably isn't true, because if it was, then the Earth's tilt, the Earth would turn around like this around the Earth, which would move its tilt constantly, which would make that we don't have any seasons. But in this theory, the Earth turns around the center of gravity just like this, and because it does this, the centrifugal force on every point of the Earth is equal, just because they are doing the same circles at an accustomed time. You can the thing that we think are making the second bulge is the gravitational difference of the Earth. Just like if you take a glass of water and turn it around the side, just like this. Just like the glass of wine. The water or the wine bulge is at the place that is strongest away from the center of gravity, or the middle of the thing, which is, as in the reality, completely opposite of where the moon is. So it creates two bulges that is completely opposite. This theory makes a lot of sense because it keeps the tilt and the season, and it keeps the rotation of the Earth. But not that it's impossible, but I think that it's quite unlikely that two different forces would create two bulges. Thanks for today, everyone, and see you next time.
Hvor er du dum.